Good morning, my dear students. The Good morning, my dear students. We have already learned the basics of group theory. That's about the symmetry operations, symmetry elements, and different types of symmetry elements. And we have also learned the symmetry elements in simple molecules. We have started with water molecule. And as you all know, I posted a test paper and I've got your responses. I got around 28 responses. There are many more to respond, but I'm not telling the names here. Okay, but the problem I have seen is the first question. Let's take the first question. What is a symmetry operation? What is a symmetry operation? It is a well-defined non-translational movement of an object that produces an indistinguishable new orientation. Okay, it gives us a new orientation and it is indistinguishable. And as example, here I'll show you one of the answers. Here I have the names on the left side. I've hidden it. You can see the first answer, symmetry operation. It's right, it is a well-defined non-translational movement of an object that produces a new orientation that is indistinguishable from the original object. Okay, and as example, you have given a water molecule with the plane of symmetry. When a water molecule with plane of symmetry is reflected, a new orientation is formed and it is indistinguishable to the original one. I am reading the answer. You can see it here. So here, a water molecule when reflected through a plane, and you have to specify where that plane is. A plane passing through, either you should write plane passing through oxygen bisecting the angle formed by two hydrogens, HOH angle, or you can write a plane passing through all the three atoms which divides the atom into two equal halves. You have to specify which symmetry element you are talking about. If it is a plane, a molecule may have more than one plane. Not necessary, but it is possible. In that case or in any case, you have to specify through which molecule, through which atoms, or the way in which the plane or an axis is passing through. So in the case of, if you are saying the plane of symmetry, you should specify when reflected through the plane passing through oxygen and bisecting the two angles, we get a new orientation. Okay, we get a new orientation that is indistinguishable from the original one. Here you have written here, the reflection is the performance done. It's not the performance done. Reflection is the operation performed. The reflection is the operation performed and the plane is the symmetry element. Okay, plane is the symmetry element and reflection is the symmetry operation. It's the operation performed. And what's amusing is you can see exactly the same answer for many. See here, it's the same. For example, when a water molecule with plane of symmetry is reflected, a reflected water molecule is formed. Reflection is the performance done. Have I mentioned in my class that it's a performance done? Because I see that most of you have written the same answer. Please clarify that, okay? And I conducted this test paper because I'm not sure if you have got the points what I'm telling you. So from this, by reading this, I can clarify where all it's required. Okay, so that's the first question. What is a symmetry operation? This much is enough. Like I told you in the first answer, It's well written, but there is a small correction. You have to write where that plane or where that axis or where the point of reflection, point or a center of inversion, any symmetry element or operation, you have to specify where it is in the molecule, where exactly that point or that line or that plane is passing through. Next question is, what is meant by symmetry element? Okay, what is a symmetry element? The symmetry element is a point, line you can write line, or it's an axis. So what is most important is it's an imaginary point, plane or an axis about which the symmetry operation is performed. Here also we have the same answers, exactly the same wordings. Okay, then with example explain any two symmetry elements. That's the next question. Okay, you can when you are mentioning there are 5 symmetry elements, you please write down which are the symmetry elements of which you are going to explain any two. Okay, and symmetry element you have here you have mentioned about plane of symmetry and inversion center or center of symmetry. Or you can write any other identity element. It's a simple one. Identity element. Then there is axis of symmetry. Any two. Coming on to the last question, what are the symmetry elements present in water molecule? So you should begin this is a well written answer. You have to start the answer by saying water molecule has a V shape. The water molecule has a V shape, and in this you cannot draw the shape, whereas in a paper you can draw the shape and then explain. Okay. Thus, the water molecule has the first symmetry element as identity element. If the two hydrogen atoms are similar, no change would be detected. Thus, the water molecule possesses this symmetry element. Okay, next we have which are the symmetry elements present in water molecule. Which are the when you have a question like this, which are the symmetry elements present in water molecule? This is how you can write it down. Water molecule has V shape, and then you draw it. Then you can write the water molecule possesses the following following symmetry elements. The first one, identity element. The first one you should write identity element, and then you can write it as capital E. Next one you can write axis of symmetry. While writing axis of symmetry, you should write water molecule possesses axis of symmetry. The water molecule there is an axis of symmetry. The axis passing through oxygen bisecting the angle formed by two hydrogens. That is the HOH angle. Okay. And you should specify rotation through 180 degree gives similar appearance. Therefore, the axis of symmetry in water molecule is two-fold axis. So it can be written as C, capital C suffix 2. So it is C2 axis of symmetry. Okay. Then we have plane of symmetry. Plane of symmetry, again you have to write down. Water molecule possesses two planes of symmetry. The first plane passing through oxygen bisecting the angle formed by HOH, bisecting the molecule into two equal halves, dividing the molecule into two equal halves, and the other plane of symmetry is the plane passing through all the three atoms, dividing all the three atoms into two equal halves. Okay. So, and it is denoted as sigma. It is denoted as sigma. Then we have, that's all we have. For water molecule, we have capital E, element of symmetry, comma. Then we have capital C, suffix 2, C2 axis, comma, sigma. Sigma is the plane. We have two sigma planes. Okay, this is how you should write. I hope it is clear for you. Similarly, please try for BF3. I hope you all know the shape of BF3, boron trifluoride. And next I want you to try ammonia, NH3. Okay, try these two and uh, you should post your answers. Either you can post it in the WhatsApp group. I think that's better. Please post your answers in the WhatsApp group we have. Okay, you try these two and post your answers through WhatsApp. You all will be having my personal number. You please don't post it in the group. You post it to me personally. Please do mention your name. Okay, thank you.